Lesson 9 is all about points, lines, rays, segments, angles, and perimeter. And when we look at this lesson, we start off with some key vocabulary. Now we're going to draw pictures for our key vocabulary. A point is just an exact location in space. So we could have a point like this, we could have a real small point, we could have a big point. Points frequently fall on number lines, like we've seen before. Sometimes they fall on coordinate planes. But a point will just look like that. They could be very small, they could be very big. A ray, if we look at what a ray is just like a line, except it has a point on one side where we start, and then it continues forever and ever in the direction we want to go, and we show that with an arrowhead. Now a line segment just has a start and a finish, and either side could be the start or either side could be the finish. We can measure the distance of line segments because they start and finish, or they start and they finish from back to front. A line, well, a line we're not going to be successful in measuring its entire length because it goes on and on forever in both directions, like a number line. So we've got the arrowhead on the left and we've got the arrowhead on the right. We've got to make sure we know exactly what those mean as we work through this lesson. Now, this problem says, in the figure, AB is 3 units and AC is 7 units. Find BC. This is a problem asking us to work with different distances. So A to B, we look at A to B from our blue dot to our blue dot, that's 3 units. So A to B is 3 units. If we look at A to C, that's all the way across, that's 7 units. So from A all the way over to C, that's 7 units. What we need to do is figure out how long BC is. So if we know 7 is the total, 3 is part of the total, what must we have here in order to add to get a grand total of 7? Well, hopefully you said 4, because 3 plus 4 is equal to 7. So from B to C is equal to 4 units. And we can go ahead and put a box around that because that's going to be our answer for this question. We've got some more key vocabulary. Please pause now and write this down. Alright, hopefully you've copied all 3 vocabulary words. The first is an acute angle. And an acute angle is just one that is less than 90 degrees. So, an acute angle may look something like this. We've got 2 rays joined here. Where 2 rays meet, that is called a vertex, V-E-R-T-E-X. And our angle is less than 90 degrees. This looks like it's about 40 degrees, maybe 45 degrees, but it's less than 90. A straight angle is exactly 180 degrees. So 180 degrees is going to be our vertex. We've got 1 ray opening to the right and 1 ray. Whoops, let's go ahead and undo that. That one didn't come out very straight. Opening to the left. It's a little bit better. So this opening is 180 degrees. If you want to use the degree symbol rather than writing out degrees, that's fine as well. An obtuse angle is greater than 90 degrees and less than 180 degrees. So if we've got an obtuse angle, that might look something like this. So we've got our vertex, it's right in the center. We've got our 2 rays coming off from that. We can see this is greater than 90 degrees. Maybe this is about 120 degrees. Let's look at one more. Let's just make sure we know exactly what 90 degrees is. Exactly 90 degrees. We've got our right angle. Okay, exact right angle is always shown with the box in the corner where the 2 rays meet the vertex. So this would be a 90-degree angle or a right angle. Okay, hopefully you have all this. When you do, we're going to move on. If not, pause now so you get this down into your notes. Okay, we want to find the measure of the angle below. Now this is 2 rays, so I'm going to add the arrowheads on. Computer doesn't do it automatically when it makes these perfectly straight lines. And if we want to find the measure of the angle, we're going to have to use a special tool. Let's go ahead and use this one. This tool is called a protractor. Got to make sure we know how to spell that as well. And this protractor, if we want to use it, what we can do is we can go ahead and we can take our protractor and we're going to center the center right here of our protractor where these lines meet, the perpendicular lines meet. We're going to put it right on that vertex. So we'll get it as close as we can. A little bit down. That looks very good. We've got the horizontal line lining up with 0. That's perfect. And we can see that this goes right through 30 and 150. Now it's important to know that this is a 30-degree angle. And I know that this is a 30-degree angle because it's acute. It is less than 90 degrees. If this angle were obtuse over here, it would have to have been 150. So when you look at this, if you've got a protractor that has both the 30 and the 150 next to each other, you need to think, is this angle acute or obtuse? When you have your answer that the angle is acute, you know it's going to be the smaller number, the 30 degrees. Alright, for our next problem we can go ahead and get rid of this protractor. What we want to do is find the perimeter of the figure. Dimensions are in meters. So perimeter. Perimeter always means the distance around the outside. So if we're looking at the distance around the outside, we'll take a moment to write that down. Distance around a figure. What we're going to do is we're going to add up all the sides. And we can see this is like two rectangles that are joined together. We've got, well, we're just going to start from the 10 and we're going to work our way around. We've got 10 plus 7 more. That takes care of our first three sides. Plus 8 plus 17 plus 15. Now when we add those all together, we're going to go ahead and find out what our perimeter is. The sum is equal to the perimeter. So we've got 0 plus 7, that's 7, plus 7 more is 14. 14 plus 8 is 22. 22 plus 7 is 29. 29 plus 5 is going to give us 34. 3 plus 1 is 4. 5 and 6. So we've got 64. Dimensions are in meters, so around the outside of this shape is going to be 64 meters. Our sum is our perimeter. And we're all done. We can go ahead and box it. We've got our label for our unit, and we're complete. We're going to practice some more problems like this with our lesson practice on pages 37 and 38. Make sure you've got your notes completed, and I'll see you during our next class.